Hey guys, Travis Close, but in the last video, we really looked at graphs and determined if they were functions, and if so, were they linear functions? Well, remember that a linear function, basically, it's a graph and it's a straight line, and a function, it is one x value has, or each x value has only one y value. Cool. But the next section, let's suppose you're given uh, a set of points, and you want to know if these points satisfy a linear function. Well, how do you go about doing that? And what you'll really see is it doesn't matter if you have a table of the data set or even just a set of data pairs of domain and range, x and y values. The question really is, well, do the change in x, are they constant? And does that imply that the change in y is actually constant? Well, then in fact, in that case, you do have a function. Well, let me show you what I mean. Well, hey, the bottom line is I want to look at the changes because a linear function is all about the changes. Well, I really want to look at what's the difference. I want to look at the change from here. Oh, let's undo that. From here to here. What's 4 minus 2? 4 minus 2, well, that's 2. And then, well, let's look at the difference. It's all about the difference. Between 6 and 4 is 2. Between 8 and 6 is 2. Between the difference from 10 and 8 is, it's also 2. Well, this change in x, it is constant. But the question is, hey, what's the change in y? What's the difference here? Well, that is 3 minus 4 is negative 1. What's the change in y again? Well, 2 minus 3 is negative 1, and so forth. And 0 minus 1 is negative 1. Well, you see that the change here, it's always negative 1. Well, what does this mean? Well, constant changes in x conforms to constant changes in y, well, this implies that, yes, since I have a constant change in both x and y, well, there is a linear function that is taking place. That's what this means. So if there are constant changes in x that imply there are constant changes in y, well, that means there is a linear function.